In this lesson, we're going to focus on how to read a T-distribution table. T-distribution table. The thing about a T-distribution table, and you'll note immediately that it looks different from a Z-distribution table. The first thing we need to know about a T-distribution table is that the results are one-tailed results. And so when we have a T-distribution, which looks like a Z, but it isn't, almost all the tables that you'll find are going to have alpha over here on this one side. And that's going to describe this as a one tail. So all of these numbers that you find in the table are one tail numbers. This guy is going to be 0.20, one tail, one tail, one tail, one tail. And what that means is we're going to do these at different, I'll show you an example in a second, but these are all one tail numbers. So when you have a two tail, if you have a two tail test, then you have to take alpha and you have to divide it by 2. Okay, so first of all, if your numbers aren't coming out when you're working practice problems, make sure that you understand that you have to run this as a one tail or as a two tail test, because all the numbers are one tails. Let's talk about degrees of freedom real quick. Degrees of freedom is equal to the total number of observations minus 1. It is that simple. Okay, let's walk through a practice problem for just a second. And in our practice problem, let's say we have a two-tail test. Let's say we have a two-tail test, and we're trying to find the left and the right side of our normal distribution, or our suspected normal distribution. So I want this x of 1 and I want x of 2. And the data that I have, and I'm grabbing this from an example that I know, is 29.85, and s is equal to 7.08, and n is equal to 7, which means we have 7 observations, right? We have 7 observations, obviously less than 30. And we're going to use an alpha of 0.05, okay? So we've got whatever it is that we have. You've got an average sample, and there's a couple of different things you should know automatically from this variable set. Number one, you have x bar. It is not mu, right? Not mu. Therefore, this tells me that it comes from a sample. This is a sample mean. It comes from a sample. This s is not sigma. Not sigma. Our s is our sample standard deviation. Again, we calculated it from a sample. So we don't know what the population looks like, right? And right away, one of the first questions we're going to ask ourselves is, do we know whether this is normally distributed? Or do we know that the population is normally distributed? And the answer is no, we don't know. Not that it isn't normally distributed, but we just don't know whether it is or isn't, because we don't have any information about the population. We have information about the sample. We have information about the sample, right? Second question, do you know sigma? Do you know sigma? Nope, I don't know sigma. I know S. I know the standard deviation of the sample. I don't know the standard deviation of the population. Number 3 is N, or the number of samples bigger than 30 observations. And in this case, the answer is no. No, it is not. We only have 7. So immediately, you should realize, or you should know, that all of the information in this set comes from a sample. We don't have any information about the population as a whole. All right? Okay, so the next thing we're going to do is identify alpha. Alpha is 0.05, and so you immediately are going to go to the t-distribution where alpha is 0.05. Alpha is equal to 0.05. That coincides with this guy. We're good to go. But our table, again, is a one-tailed table. If our table is a one-tailed table, I can't use 0.05 because if this is 0.05, in a one-tail situation, then 0.05 divided by 2 is equal to 0.025. If I have a two-tail situation, then I need to be over here where this is 0.025 and the left side is also 0.025, such that 0.025 plus 0.025 is equal to 0.05. The error, we have the same error rate, but instead of having it all in the right tail, I have it in both tails, here and here. Okay? So I have a one-tail table, but I have a two-tail problem. So instead of doing 0.05, I need to take this 0.05 and divide by 2. So I really want to look at my table as if alpha is equal to 0.025. I want to look at this column. Why this column? Because it is a two-tailed test. 0.05 divided by 2 is equal to 0.025. That is one of the major confusions that people get when they look at t-distributions. The table is constructed as a one-tailed table. If you have a two-tailed test, you have to go back and divide the alpha by 2 when you come to the table. In our case, n is equal to 7, but we're not measuring this left line in terms of n. We're measuring this left line in terms of degrees of freedom. So degrees of freedom is 7 minus 1. Degrees of freedom is 6. I'm going to look at degrees of freedom 6, and I'm going to highlight the entire row over to the right. I'm going to walk down my 0.025, and I'm going to walk over from 6 and recognize that the t value, or the critical value for t at alpha is 0.025. It's going to be 2.477. And that's going to be our answer here. 2.477. Let me zoom in here on our t. Let me just redraw it again, right? When in doubt, draw it out. We have a distribution. We know that it kind of looks like normal, but we're not 100% sure. We know we have a two-tailed test. There's my right tail. Here's my left tail. I know that this is going to be 0, and I know that this is going to be 2.447. This is 2.447 positive, this guy right here, and that this guy right here is going to be negative 2.447, such that this is alpha equals 0.025 to the left. This is alpha equals 0.025 to the right of my stat. And if I add them together, I will have alpha equals 0.05, right? This is a two-tail example. If we then turn this and look for x, we have to do our t-distribution modification, which is x bar plus and minus, right? Left tail and right tail. My t-distribution, in this case alpha divided by 2, which is what we did. This is confusing, that looks like two 2's. Alpha divided by 2 times s over the square root of n. All right, and this is going to give me x sub 1, and it's going to give me x sub 2. How do you know? Because of the plus and minus, right? Let's do a little plug and play stuff in here. Matter of fact, let's go back up here and grab 29.8, 7.08. All right. So this is going to be equal to 29.8 plus and minus our t-distribution, which is 2.447 times s, which was 7.08 over the square root of n. Note that this is going to be n, not degrees of freedom. Okay, we use degrees of freedom when we're up using the table, but we don't use degrees of freedom here. And through the magic of modern storytelling, we know that this is 29.8 plus and minus 6.54. 6.54, and that gives us 23.3 to 36.4. If we were to then draw our normal distribution as opposed to our standard normal distribution, we would get, again, a two-tailed problem that looks something like this. This is 36.4. I know that my x bar is 29.8. This is 23.3, such that this is not alpha, but that the area under the curve here is 0.025, and that the area under the curve to the right of 36.2 is 0.025. And if I add them together, the overall alpha is equal to 0.05. Anything south or left of 23.3 and anything higher than 36.4 is going to be in the alphas. It's going to be in the tails. Hope that helps.